All right, so this video is on the conic, the hyperbola. All right, so here's the definition. All right, a hyperbola is the set of all points on a plane where the absolute value of the difference of the distances between two fixed points, and again, these points are going to be called foci, that difference is constant. All right, so graphically what we've got going is something that looks like this. All right, the graph of the hyperbola is the blue part here, okay? What this definition is saying is if you take a point on this blue graph here, then take the difference between that point and this focus over here and this focus right here. Take the difference in those distances, you get a number. And it's always the same number no matter which point you take on the hyperbola. So if you take this point right here and go this distance minus this distance, right, you get a number. Yeah, and yes, you have to take the absolute value because we want the distance to be positive. You'll always get the same number, right? That's why it's constant. Right, same idea with this one, where they're opening up and down, so to speak. These over here to the left, they open right and left. These, the one on the right opens up or down. Well, there's a better way to think about it. It's called the transverse axis. For the one on the left here, the transverse axis is horizontal, right? And for the one on the right, the transverse axis is vertical, all right? For both of these particular hyperbolas, the center is located here at the origin. The vertices of the hyperbola are these two spots right here. For the hyperbola, it's got a horizontal transverse axis, and the vertices are located here and here. For the hyperbola, it has a vertical transverse axis. The foci are inside each part. So you have a foci here and a foci here for the horizontal transverse axis, and you've got the foci here and the foci here for a vertical transverse axis. Okay? And in reality here, there's actually some asymptotes that go through here like such. Follow the cursor. An asymptote that goes like this, and an asymptote goes like this, and your hyperbola follows along those asymptotes. And we'll talk about how to find those here in a few minutes. All right, so the equations for these two things would look like the following. All right, so this time we're going to have x squared over a squared, but it's going to be minus y squared over b squared. Whereas with the ellipse, it was x squared over a squared plus y squared over b squared, so that's the difference, right, is equal to 1. Right? We want x squared minus y squared. Or we could have y squared minus x squared, right? So if it's x squared minus y squared, then you have a horizontal transverse axis. And if it's y squared minus x squared, you're going to have a vertical transverse axis. Okay, make note that c squared this time is going to be equal to a squared plus b squared. No, I'm not taking the time to derive the equations for the two hyperbolas, nor am I deriving the formula for c squared. Right, but you all could find that in your book. All right, so this is the scenario for hyperbolas where their center is located at the origin. Now that leads us to the standard form for a hyperbola. Right? So note again, c squared is going to equal to a squared plus b squared for a hyperbola. Okay? For an ellipse, remember it was c squared equals a squared minus b squared. So just be careful, make sure you remember which one you're dealing with. All right, so for this first one here, you have x squared minus y squared equals 1, so you have a horizontal transverse axis. All right, and for y squared minus x squared, you have a vertical transverse axis. In both situations here, both forms, the center is h comma k. Everybody see that? Remember, h goes with the x's, k's go with the y's in both scenarios here. Okay, so just be careful. The vertices. Well, for this first one here, the vertices would be whatever the x part of the center is, plus and minus whatever the a value is. And the a value is always going to be the first one here underneath your first term. Right? And then comma your k value from your center. And then the foci, don't forget the foci are inside. Right? So the foci are like here and here. And so to get them, you do the x part of the center plus or minus whatever your c value is, and then comma k. And that gets you those points there. Right? That's for a horizontal transverse axis. For a vertical transverse axis, the vertices are going to be, well, this time you're going up or down, so it's the h, and then comma the y part of the center plus or minus the a value. And again, the a value is going to be the first one over here. Okay. Right, the foci this time, we got one located there and one located there. So it's the y part that's changing. So the foci is going to be the x part of the center and then the y part of the center plus or minus whatever your c value is. All right, so that's it for what the standard form looks like. Make sure you see the next video for a few examples on how to graph hyperbolas and how to find all this information. All right, study well. Please let me know if you have any questions.